Hello everyone, this is Dr. Daya Sagar Chowdary, Senapati, Assistant Professor, Department of Electronics and Communication Engineering, Aditya University-Surampalem. Today I would like to discuss about the topic demultiplexer. So coming to the learning outcomes, at the end of this lecture, students will be able to analyze and implement demultiplexers for distributing a single input to multiple output lines using select signals. Coming to the demultiplexer, also we call this one as a demux, performs the reverse operation of a multiplexer. So previous class we discussed about the multiplexer concept. So this is quite opposite to, that means the demultiplexer quite opposite to the multiplexer. A demultiplexer is a circuit that accepts single input and transmit it over several, that means here 1 of 2 to the power of n possible outputs. And a demultiplexer, the number of output lines is n and the number of select lines is m, where n is equal to 2 to the power of m. So here if we observe the block diagram, this is a block diagram which contains the data input. So data input is nothing but the only 1. So we can draw with the help of 1 multiplied. Now here the selection lines. So the selection lines that can be written as like this, that means 2 to the power of n. Here the n is nothing but the number of selection lines and 2 to the power of total n is nothing but the output. So number of outputs. So likewise if most of the time we start from 0 to n, that is selection lines, but here most of the time 1 to n we are taking. So if we start from 0, then this is n minus 1. So that means here the selection line starts from S0 to Sn minus 1. So likewise here the outputs that are m, we are taking the m representation, that means this is from 0 to m or 1 to m. So here 0 to m minus 1. So here the representation is, because this is a demultiplexer, simply we are using the representation with d as the output. So that is why d0 to d m minus 1. So that means total m outputs here and n number of selection lines and only one input is presented here. That means we can get this data input from the output of the multiplexer. The same output of the multiplexer is given as the input to this demultiplexer, and depending on the selection lines only the output we will get. So likewise we can take this as a demultiplexer. This is the operation in the demultiplexer. So here the representation is n is equal to 2 to the power of m and finally 2 to the power of n possibles. Now coming to the starting, that is 1 to 2 demultiplexer. So we can represent this with 1 to 2 or 1 into 2 or 1 is to 2. So likewise we have to represent this multiplexer representations. So now this is a 1 to 2 line decoder. So with enable input is also presented. So that means this is the enable signal, and the single input we are using that because for any number of any representation only one input and outputs may be differ from, that is 2 to the power of n, that is here the representation is y1 to y1 to y1 y0. These two are the outputs, and the selection line only one single selection line. That means if a single selection line is there, maybe s is equal to 0 or 1. S is equal to 0 or 1. Now output is nothing but that is y0 and y1. So if selection line is 0, it will select the y0. That means it will select the y0 means directly the input is a, that is given to y0. That means if the selection, that is s0 is equal to here, if it is 0, so y0 is equal to directly a. So this is the combination. That means if we select the s0 is equal to 0, y0 is equal to a. If we select s0 is equal to 1, then here the y1 is equal to a. So that is the representation of this particular truth table. So here y0 is equal to, finally we will get the equation y0 is equal to, that is this is the product of this particular. So wherever s0 is equal to 0 representation means that is equal to s0 bar. So that is multiplied with the input. So this is s0 bar into a. So this is the y0. If we consider S0 is equal to 1 means directly we can take this one as a S0 with the help of the input, that is A. So S0 into A, that is nothing but your Y1. So Y0 and Y1 we can consider the equations like this. So this is a simple 1 to 2 demultiplexer. Now coming to demultiplexer, that is 1 to 4 demultiplexer, the block diagram is same, and again the input is only one, that is A. Here the representation is Y0, Y1, Y2, Y3 are the 4 outputs. And coming to the selection lines, S0, S1 is the selection lines. So now most of the time the construction of this particular circuit depends on the selection lines only. So that means we are simply following the binary combination of this particular selection line. That means because here the selection lines are 2, so we can construct with the help of these 2 selection lines, there are 4 combinations, that is either 0, 0, 0, 1, 1, 0, 1, 1. So S0, S1 are like this. So S1, S0 are like this. So we have to first of all make this one as a product term. So with the help of this AND gates, we are constructing this product term. That means S1 is equal to 0 means bar, S0 is equal to 0 means bar. So we have to take 2 inverter gates and constructing with the circuit, that means both 1 and 0. So totally we will get the 4 combinations. That 4 combinations is given to the AND gates, and finally we are getting the output. So if we observe this Y0, so that is the input signal, that A is connected directly to the Y0. Here the Y0 is connected, and both the selection lines, so after inversion of the selection lines, that means S0 bar and S1 bar. So S0 bar and S1 bar is given to this particular AND gate. So that means these 3 connections, terminals that are connected to the AND gate, and finally we will get the output that is equal to Y0. That means if we write the equation S0 bar, S1 bar and our input A. So this is the equation for this particular Y0. So if we consider the equation for this Y1, so if we consider this one, so A is common, so A is the input, that is common, and S0 is after here S0 is directly given, that means here S0, and S1 is after inversion only we are giving, so that means S1 bar. So likewise we have to construct one time here this is Y2 is equal to S1 S0 bar A, and here Y3 is equal to S1 S0 and A. So likewise we can construct simply the S1 and S0 following the simple binary combinations. So here also S0 S1, so here the 4 combinations are there, the binary combinations. So each time that A is directly given to Y0, so Y0 is equal to A. Here the A is given to Y1, so Y1 is equal to A. Here A is given to Y2, so Y2 is equal to A. Here A is given to Y3, that is equal to Y3 is equal to A for both the selection line 1, 1. So here likewise we can construct that particular equation, and we can draw the truth table for this particular demultiplexer, that too 1 to 4 demultiplexer. Now coming to the 1 to 8 demultiplexer, so the combination, again the selection lines are 2 to the power of 3, that is equal to total 8 combinations. So here simply the selection lines are following the binary concept, that is 0, 0, 0 to 1, 1, 1, totally 8 combinations we will get, and according to the same construction 1 to 2, 1 to 4, 1 to 8, so same connection. If we observe the input, that is diagonally, so if we observe the input, so for each and every combination, so A is given to the Y0, here A is given to the Y1, A is given to the Y2, and A is given to the Y3, likewise. That means we will get Y0 is equal to A, Y0 is equal to A for 0, 0, 0 combination of the selection lines, and Y1 is equal to A for the selection lines 0, 0, 1. So likewise we can simply consider this combination. So finally we will get all the that Y7, and this is the final bit. So Y7 is equal to A when the selection lines are 1, 1, 1. So here this is the block diagram contains the selection lines S0, S1, S2, and the output lines is from Y0 to Y7, and the input is again the same, that is only one input, that is A. So here again the circuit construction, again we will form the binary format, that is equal to S0 line, and after inversion S0 bar, this is the S0 bar, S1 and S1 bar, S2 and S2 bar. So likewise we construct the binary from 0 0 0 to 1 1 1. So the 3 combination is given to this particular AND gate. So for this particular AND gate, and directly the input, so here the A is the input that is connected to this particular AND gate. That means each AND gate contains 4 input terminals. So if we have if we want to draw the equation Y0 is equal to, so S0, because that is in after the inversion only we are taking the selection input, so that is why S0 bar, and again S1 bar, this is also after inversion only we are taking, and next S2 bar, so this is also after inversion only, and finally our input is A. So that is the product of S0 bar, S1 bar, S2 bar, and A is nothing but the Y0. So likewise we have to draw or write the equation for all these from Y0 to Y7. Likewise we have to construct for higher order, that means not only from 1 to 2, 1 to 4, 1 to 8, also we are having 1 to 16, 1 to 32, because the outputs are at the time of 2 to the power of n. So likewise we have to construct. Always we have to remember that n is nothing but the selection lines. And coming to the advantages, so efficient data distribution, because routes a single input to one of many outputs using select lines. That means here we are giving one single input as an input, and we are getting so many outputs, so 2 to the power of n outputs. So we can get the output from only single input. So that is the advantages. And reduces wiring and hardware complexity. So because of this particular device we can reduce the complexity, so we can reduce the wire, so that is why we are simply reducing the complexity also. And useful for address decoding. So most of the time these demultiplexers are used for reduction in the circuitry. So here I gave 2 examples. So most of the time used in the memory, at the same time IO devices, that means input and output devices. In order to select the input and output devices, most of the time we are using this particular demultiplexers. So flexible control, that means output selection can be changed dynamically by input selections. Also supports serial to parallel, because here serial means the data is single, so serially. So if we consider 1 0 1 1, likewise the serial input, and we can get the parallel output. That means we can get all the bits, so 1 0 1 1, so we can get it as a parallel. So most of the time these concepts are used in the GPUs, so graphical processing units. So likewise we are using these are the advantages for this particular demultiplexer. Now these are the limitations, disadvantages of the demultiplexer. So requires accurate select lines timing to avoid incorrect output routing. So this is one of the drawback, and long wiring and more outputs can increase propagation delay. Maybe it will produce some propagation delay. Propagation delay is nothing but to change the output, the time required for the input is nothing but the propagation delay. So this is also one of the drawback for this particular demultiplexer, and cannot function without an external clock or control signal for dynamic routing. So here we are not discussing about the clock signal for this particular demultiplexer, because this is a combinational circuit. For combinational circuit the clock signal is not required, so that is why, so there is no requirement of clock signal. So most of the time we are using the enable signal, so or here the control signal is also not there. So for this particular problem, so this is the disadvantage for the demultiplexer. And noise and interference may cause wrong output selection in high speed systems, because there is no control signal. So always the device is in on condition, because there is no control signal. So that is why most of the time maybe there is an interference in the noise signal. So we can take this one as a disadvantage for the demultiplexers. And coming to the application part, most of the time wherever we require the data distribution, we are using this demultiplexers. So that is why distribution from one source to multiple destinations. So we can take this one as an example for broadcasting. Broadcasting means the TV channels. So there is a TV channel, so only one TV channel, but the receivers are, we are having all the TVs in our homes. That means this is a demultiplexer concept. That means we will get more number of outputs, but the source is the only one, that is TV channel. So maybe let us consider this one as a series TV channels like ETV, Ma TV, likewise, but the output are all the TVs in our homes. And used in communication systems for serial to parallel conversion. This is what we are discussing. So most of the time this is the major application for this particular demultiplexer. Implementing decoders and address decoding in memory circuits. So most of the time this demultiplexer is a selection for the inputs and outputs. So that is why we are using this circuit in the computers, mostly in memory element. So it can demultiplex, that means it can transfer, select the whatever the data that is there in the hard disk, and it will give to the screen, and again it will go back. That means it can save the data again to back. So this is the concept. And controlling multiple devices, that is LEDs, motors, relays. So in order to select, if we are having so many outputs, definitely we can control with the help of this particular device. And channel selection in TV and radio receivers, again in order to select the whatever the application, we can use this one as a selection part. And routing digital audios or video signal. So again digital audio signal, video signal, we can use this demultiplexer circuits in this particular application. Coming to the summary, so a demultiplexer takes a single input and distributes it to one of several output lines depending on the selection inputs. So it is mainly used for signal distribution, decoding and communication systems. Thank you.